Hello and welcome to section 1.9. We are going to talk about the periodic table. And here we have a periodic table right in front of you. This periodic table has been color-coded to show us which elements are metals, which ones are nonmetals, and which ones are metalloids. The blue elements, all of these here, are metals. It's most of the periodic table, actually. We have nonmetals over here on the right, and we have just a few elements right here that are metalloids or semi-metals, they call them. So let's take a look at this a little further. Metals. What constitutes a metal? What makes something a metal? Physical properties of metal include their ability to conduct heat and electricity. Metals are malleable. That means they can be hammered into a flat sheet. They're ductile, which means they can be drawn into a wire. And they have a lustrous appearance. And luster is basically the sheen or reflective quality that a substance has. So these are the main properties, physical properties of metal. When we talk about nonmetals, the physical properties are basically that they lack metallic properties. Nonmetals they vary greatly. There are so many different kinds. Some of them are gases, some are liquids, some are solids. They vary a lot. Here we have just an example. Here's helium, and we have different elements that make up neon signs, and a whole bunch of different noble gases can make up the neon signs as well. So they just have a lot of different properties, and we generally just say that they're lacking the metallic properties. And when we talk about semi-metals, or metalloids, sometimes they're called, they basically show a mixture of properties, and there aren't very many on the periodic table. We have silicon, germanium, arsenic, antimony, and tellurium. Sometimes boron is considered a semi-metal, and sometimes polonium and astatine. So you'll see a little bit of variation on the very upper and lower end of the periodic table as to whether some of those are included. But semi-metals basically show a mixture of properties. And here we have a periodic table showing the different families of elements. And those are really important to know because elements that are in the same family tend to have a lot of properties in common. For example, over here we have noble gases. Starts up here with helium, neon, argon, krypton, xenon, and radon. Those are all in this noble gas family. And we'll be talking about that a lot later. They're very unreactive or inert, and that's where they get their name. They don't like to react very much with other atoms. Here we have the halogens. The halogens are very reactive. They include fluorine, chlorine, bromine, iodine, and astatine, and those elements are all in the halogen family. We've talked about the metalloids right there. That's not exactly a family, but those are some metalloids, just so you remember where those are. The transition elements, these are called transition elements, and we'll find later on when we start talking about energy shells that the transition elements have some unique properties. The lanthanides and actinides are elements that actually fit in here in the periodic table. If you look at this long version of the periodic table, they included the lanthanides and the actinides in the actual table, but it's just awkward and very wide. So most periodic tables put them down below like this, and they're named after the element here, lanthanum, and here, actinum, that begins the series of each of those. Here we have the alkaline earth metals. Some of the metals that you would recognize: beryllium, magnesium, calcium. Those are in this family. And the family on the far left are alkali metals. and those include hydrogen, lithium, sodium, potassium, and others. But these are important for you to get familiar with so that you know what we're referring to when we say the halogen family or the noble gases. Here we have a list of elements that exist as diatomic molecules in their natural state. So when you see naturally any of these molecules, they will exist diatomically. They travel around in pairs, in twos. So we have hydrogen, nitrogen, oxygen. Those are all very common gases that we encounter, and they are all diatomic molecules. Fluorine, chlorine, bromine, iodine, those are all halogens, and they are all diatomic as well. So what could you do for a 4? I'll let you look some of these up. Maybe you have some ideas that you could come up with on your own. This was sort of a short little section here, and I'm sure you will feel challenged to go above and beyond and think of some more research to do and dig a little deeper. So thanks. I look forward to seeing what you have.